Hello guys and welcome. I hope that you're doing well. My name is UHD King, or I play 4K, AK, I play 8K, AK, I play 16K, and during this video I'm going to demonstrate ChatGPT, artificial intelligence powered by OpenAI. I'm going to show you how I'm doing the researches. This is going to be my third application that I'm trying to develop with ChatGPT. I did so successfully in two previous little applications. So this is going to be a big application. So pretty much as a few of you probably are aware that I was developing the retracing benchmark. To provide value as PC hardware enthusiast, PC overclocker, software developer, game developer, graphics designer, 3D artist, and I'm trying to develop a benchmark application, benchmark software that will be able to test your CPU, all available CPU cores, CPU threads that is available through very heavy tasks that are going to utilize no matter what kind of CPU you have at 100%. And what I learned, the best way to approach that will be to develop an application that's going to utilize the retracing on CPU instead of GPU, which is GPU is much faster, but on CPU. Okay, and I was developing that over 4 months, and then Ukrainian war started, and I did a pause because I was under heavy emotional distresses. And now I'm coming back, and now I'm playing with artificial intelligence, which is Chat GPT. It's artificial intelligence that capable to write a software, capable to do anything. At least it's 10x from the regular human, not from a regular human, but from the professional human on that topic. This is the first public version that was available like 3 months ago, and I'm going to utilize it today. I'm going to show you how to combine your own skills with the artificial intelligence. Okay, so let's go ahead and get going, guys. I'm going to show you how I'm going to replace 4 months of my software development in about 2 hours. Okay, this video is not going to be as fast as possible. This video will be about a couple hours. If we're not going to get disconnected, if we will get disconnected, I'm going to split this video in multiple parts. But today I'm going to show you how I'm going to do the research. Okay, and then in the next part I'm going to pretty much use that code, and then we're going to progress after that point. So at least it's going to be 2 parts. It depends if we're gonna get kicked out or not, but look like the ChatGPT by OpenAI is overloaded right now. A lot of millions of people are using it, and as again, this is the first public beta, and they do not have a lot of resources yet. They just got allocated $40 billion for them in January 2023, which $10 billion by Microsoft, and another 30 billions from all kind of different companies. Okay, so I logged in at the chat.openai.com/chat, and I'm going to start new chat. And just by typing here in the box, I'm going to ask the AI. It's going on in real time. I'm not going to do any scripts. I'm doing as we're gonna go, guys. Okay, and keep in mind that audio track that is playing right now in the background is all rights reserved. I have the commercial license, guys. I just woke up. It's 8 a.m. over here, Central Time. And let's go ahead and get going. So I'm going to ask it. I'm going to say hi. Come on, my name is UGD King, and I am an innovator, software developer, computer scientist, graphics designer. I'm just going to introduce myself to it. It's a great idea, so it's going to remind me and use me in the future as AI. 3D artist and a gamer. My goal is to develop and innovate in new technologies that can be utilized by humanity while providing a value. Okay, so I'm going to start it, and then I'm going to ask, let's see what it's gonna do. So it's answering in real time, guys. As again, this is not going to be scripted. That sounds like a very ambitious and admirable goal, UHD King. It's great to see someone with such a diverse set of skills and interests of working towards making a positive impact on the world. Is there a specific area of industry you're focused on with your innovations and development efforts? Software development, AI, graphics design, 3D animation, and game development. That's a great combination of skills and interests. With your background in software development, AI, graphics design, and 3D animation, you have the potential to make significant contributions to the field of video game development and interactive media. Additionally, your understanding of AI could allow you to develop the new tools and techniques that could be used to improve the performance and realism of virtual characters and environments, or to create new types of gameplay experience. And by utilizing your skills in graphic design and 3D animation, you could create stunning and engaging visuals for your games. It's great that you want to use your skills to provide value for humanity. Your understanding of AI and gaming could lead to innovation solutions for fields such as education and training, healthcare, or even psychology. Keep up the good work and let me know if you need any help. Wow, guys, I didn't script. I just started. I never introduced myself, by the way, to the AI before. So let's go ahead and start on the retracing. So today we're gonna develop a CPU retracing, multi-thread CPU retracing. So I'm gonna show you how I'm doing the researches while I'm thinking as software developer and innovator, and kind of structuring some ideas and brainstorming towards the new application development or software development. So retracing through the CPU. So I'm gonna let the AI know, please provide a multi-threaded example of retracing on CPU while utilizing every thread at 100%. Please provide an example of basic retracing on CPU. Okay, let's start with that. Here's an example of basic multi-threaded ray tracing algorithm implemented in C++. I don't want to use the C++. So let's go ahead and see when it's going to finish that. I'm going to utilize the C#, because I'm comfortable with C# as object-oriented programming language. Guys, I'm comfortable with C#, PHP, HTML, a little bit of Java, JavaScript, I would say, Visual Basic, ActionScript 3.0, which is Flash computer programming language, which is dead by now, and a couple more languages, but not too much with the C++. So we're gonna switch our topic. Okay, let's see when it's going to be done. And I'm going to use the C# in this project. And hopefully the C Sharp, look like C Sharp language in 2022 is moving to as multi-platform language, not only for the Windows operating system, but is also supported Linux, Unix a little bit, and moving towards the mobile platforms. So hopefully it's going to be supported by all kind of platforms, including the iOS and Mac OS, and the goal is to develop something that's going to be supported on all kind of different computing systems, so we can use this benchmark, and hopefully it's going to be popular as 3D Mark or Future Mark, and we're going to find out, guys. I'm trying to make it as open source. We'll see how it's going to go. Transparent freeware, transparent freeware. So what I'm gonna do, I'm going to rephrase that. I forgot to say it. C Sharp. Let's go ahead and copy it and paste it. So you can see it's responding, guys, in real time. Please provide C Sharp code. As you can see, it can write all kind of different codes, guys. It's not limited to coding. It's not limited to software development. It can answer any question that you like. This is what it's best about it. Keep that in mind. So I will try to explain as for beginners that watching UHDking.com YouTube channel. As you can see, today we are not about the gameplays. Today we are not about 16K UHD, about 16K video resolution. Today we are about software development. But over UHDking.com, we're going to learn a lot of 3D graphics design, game development, games, and software development, guys, web development as well, and hopefully mobile development, such as for iOS platform and Android platform. So please provide C# code as multi-threaded example. Here we go. Guys, I'm sipping some hot chocolate with the premixed with the coffee. Not so healthy drink. The healthier drink will be the tea with 2 lemons, or the best will be water with the lemons, but tea is some fancy, and this is too much fancy, but not great when you're drinking too much. It's not great for your blood, what I learned. I just woke up. AI could disturb my voice a little bit because it's snowing outside and it's so cold, so I'm using some heat. My heater in the house is enabled, so it's kind of noisy, and AI is removing the noise out of my voice in real time. So it could distort a little bit of my voice. Hopefully it's not. Here we go. We're from C++. We're doing the C#, as you can see, and yeah. And it's coming at the same time. It's coming in the code, and it's coming as an example, and you can add and you can ask additional questions. This is unbelievable, guys. So as you can see, it's going to replace the senior software developers, and I believe that AI field will create additional industry, which will be AI administrators in the end of 2023 and 2024. So it's going to be a new workers will be hired by the companies that will be utilizing the AI. At the same time, they should be knowledgeable. Let's say if you're doing the code, you should be knowledgeable on a topic, so you can manipulate and you can pretty much finalize and build the final idea for your product or services through the AI, but to stick it and put it together, which will save time dramatically. You're gonna learn throughout this video, guys, as examples, and I'm going to provide a lot of tips because this is going to be the third application that I'm using while I'm using the AI. And I started learning the AI since 2020 while I was doing my modes for cinematic modes for Quake 3, Quake 2, and Quake 1, as well as Stalker, Call of Pripyat PC games, and now I'm using it as the software development as well. Not only for the graphics, not only when I'm going to manipulate and redraw the pixels, but now as a software developer, as AI, I'm using AI as assistant. They're going to boost up the production by 10x as minimum while it's in the beta version, but I believe it's going to boost up by 100x over a human that is computer scientist or any scientist. So sure, here's an example of basic multi-threaded ray tracing algorithm implemented in C# using the system trading namespace. Okay, system trading, guys, is used to get the threads, amount of threads and cores. So it's going to, after that, it's going to probably count all the threads available on the CPU, so it's going to utilize them all through some approaches. So retracing, let's create the class retracing. As you can see, it's using the C# regular dependencies. Most likely it's going to work no matter what kind of platform you're going to use. If it's going to be supported, C# language will be supported. Okay, so it's creating main function with height, look like pixels for the image. Thread. Hopefully you speak a little bit of C#. You capable, when I'm saying capable speaking, capable to program. Okay, start, so it's calculated data traces. Okay, kinda simple, but doesn't give us an idea how it's doing the retracing. So it says, as you can see, that it's doing something, but as again, let's go ahead and get it going. But it's pretty much show us how to do the multi-threading. So it's calculating number of threads available on CPU, and then it's trace race. It looks like it's doing some retracing, and this is passing it, and it's doing some multi-threading retracing capabilities in real time. But as again, doesn't show how it does it. So let's go ahead and start. As you can see, it's explaining here an example, the trace race. I really like when the AI is naming the methods and the classes and the variables exactly what it is. It's so smart, it's unbelievable, just like human being. Function is called by each thread. Okay, just like I explained to you, makes sense. We saw it in the code, but let's go ahead and read it, guys. I'm not gonna focus on the code. I'm gonna read whatever the AI gonna tell us, but you want to pay your attention if you're a software developer, programmer, what it's writing as well. Press pause, and you can pretty much try to do it in your Visual Studio or any C# IDE. The row to process parameters is used to determine which portion of the image each thread is responsible for. Okay, so each thread on the CPU is responsible for some portion of the image while it's building that image in real time while through the retracing algorithms. The blocking collection type is used to manage the rows that need to be processed by the threads. In this example, each thread is responsible for retracing one row of pixels for every num threads, which is the method probably rows, so that each thread is working on a different portion of the image. In the main function, the number of threads is determined using the environment processor count, just like I told you guys, property, and the threads are launched using the thread constructor. Each thread is then, so pretty much as you can see, if you're a software developer or programmer, you understand that this is pretty much the idea of C# language. And it's you gotta be familiar with C# syntax a little bit, at least to understand fully what is going on in this video, because we're going to use the C# language as an example. Each thread is then joined to the main thread, and the program returns after all the threads are finished. Okay, keep in mind that the example provided is very basic representation, just like I explained it to you guys, of how to use multi-threading and retracing, and there is no much efficiency and optimization ways to done so, but it should give you a good starting point. We didn't see how it's doing the retracing yet. It's just using that method of the retracing and then splitting it. Please note that thread slip 1000 is only used here to wait the end of the old threads. In a real world scenario, you should use a proper synchronization mechanism such as manual reset event or countdown event to wait all the threads to complete. When the whole production processes will be complete instruction on the CPU threads, then it's going to be done. It's not going to be wait any longer. Otherwise, it's going to put the application in the waiting. Okay, so you cannot manipulate until it's going to be done. Okay, let's go ahead and start. You can type continue. As you can see, guys, previous ChatGPT application over OpenAI.com had here show different examples, but it doesn't. I think just because it's overloaded, millions of people using it, they remove this option. But you can manipulate it by asking all kind of different questions. What I'm gonna do, you can also ask continue, and it's going to continue. Let's go ahead and ask continue. If it's not going to continue, if you're gonna see it's kind of try to summarize the thing and doesn't approach to any other answers or any other replies towards the topic, then you can ask the questions, and I'm going to show you some tips how to do that properly, okay, when you're a software developer. And it's going to be easy for the beginner as well. So continue is a great method when you're using the ChatGPT. Sure, here's another way to wait all the threads to complete using the manual reset event. Okay, so it's kind of continue to tell me when the application will complete with the instruction set towards that task. So didn't understand where we are approaching. So it's continue kind of in not what I ask more on retracing, but it's continue how to complete the application with that task through the multi-threads on the CPU. I really like the way it's coming as well, like a human being. And it's not like some human beings like commenting, you cannot understand what it's all about, even if there is any comments. Over here it's beautiful. As you can see, they're using kind of C# application as console, so it's capable to run on all kind of platforms. But I'm going to probably use it as Windows application, so I gotta change that console write line to something else, probably to label .text on a C#. The time we are using a manual reset event object that is created in the main thread. Each worker thread signal completion by discriminating a counter, and when all threads have completed, the counter will be 0. The last thread will set the event and the main thread will continue. This version of the code is more robust because if one of the threads throws an exception, it will not prevent overthread from completing. Okay, it just explained how better way to approach while creating your application. If there is an error, it's still going to complete, and with the minimum type of errors. Please note that this is just one of the many ways to synchronize threads, and depending on the specific requirements of your application, as again, it depends the way you're approaching. The software developer will understand that programming a lot of application on C#, other synchronization mechanisms may be more appropriate. Okay, all right. I can continue, and it's going to, as again, talk about the processor count and synchronization. We don't want to do that, so I'm not going to type here continue. And also, as you can see, when you see that it's closing the whole code and closing the class retracer over here, that means we are done. Sometimes when it's not closing, you ask continue because it limited to a certain amount of the characters. That means that a ChatGPT is not finished with the thought, it's just limited, and you gotta ask continue, so it's going to throw out more code into you. Okay, hopefully guys this makes sense. Alright, so if I'm going to ask continue, it's not going to continue on my thought. I want to ask the example of the retracing. So what I'm going to do, I'm going to say please extend the code. You don't need to say please. Extend the code with basic retracing um, example with comments. Sure, here's an example of basic multi-threaded ray tracing. So understand that it's multi-threading because it's extending. So while you under that chat, it's going to work on that topic and then understand what was previously, which is nice. Sure, here's an example and it can combine. Here's an example of basic multi-threaded ray tracing algorithm implemented in C# using the system.threading namespace with comments explaining what each part of the code is doing. Okay, as again, please press pause if you're trying to duplicate this experience, which is nice, especially if you're beginner to learn and see the results. It's probably not going to finish its thoughts, so I'm gonna say continue. You're gonna see it. So it created the static void trace rays method, as you can see, and but there is a lot of things to do. It didn't complete it yet, so we're gonna ask. I'm gonna ask for the basic retracing calculations, extend with the basic retracing calculations. So I will ask now whatever it put in those comments to do. I'm gonna ask it to finish up, to extend the code, and then we're gonna advance the retracing capabilities. Okay, in this example of the trace race function is called, it's not function, it's kind of method, but in other languages it's called function. Keep that in mind, depends what kind of language you're using. It's called by each thread. It's probably meaning function in terms of the different thinking, not to be specific to the syntax. The row to process, look how the way it's calling the methods, it's unbelievable. Parameter is used to determine which portion of the image each image thread is responsible for. The blocking collection, we already heard that. Type is used to manage the rows that needs to be processed by the threads. In example, each thread is responsible for retracing one row of pixel. Okay, now it's extending the explanation for every, and it's tell us how it's going to use the multi-threading on your CPU throughout the functionality of our application. Of pixel for every number threads rows, as again in quotes, it's a method that is using under the class, and method can have some variables as well, so that each thread is working on a different portion of the image, and that method you can find in the code. In the main function, let me go up a little bit so you're gonna see. In the main function, the number of threads is determined using the environment process count. We already know that property, and the threads are launched using the thread construction. So already repeated. Each thread is then joined to the main thread using the we'll learn about that. Keep in mind that example provided is very basic representation of how to use multi-threading in retracing, and there is much more efficient and optimized ways to do so, but it should give you a good starting point. Okay, so what I can do now, just because I kind of I know where my vector is approaching, but let's say ultimate beginner. Let me start with the ultimate beginner. But if I'm not the ultimate beginner, I'm just going to ask it, please, because I know exactly what I want to do. But as again, not ultimate beginner, but I studied the retracing about 4 months. I read a little book, and I was following the Polish retracing developer that created a beautiful retracer under the Java multi-threaded retracer. But I don't want to use the Java, even if Java is from start multi-platform language, and but it's easy to decompile it and it's easy to hack it. I want to make a benchmark, and I'm going to use the C#. And I'm more familiar with the C#. Even if Java is close to the C#, it's like 90% even the syntax close to the C#, and the whole object-oriented language is looking just like a C#. C# is a Microsoft programming language, and Java was, you know, by Sun, and then it was purchased. Anyways, so what I'm gonna do, I can use the vector approach, which will be pretty simple. Let's go ahead and create the scene. Let's go ahead and create the 3D primitive, which is 3D object, and set the light and show the basic of the retracing. But let's say if you don't know, if you're not at that level, but it's nice to be at that level. It's nice to know exactly what it should do, at least to imagine this in your brain, even if you don't know how to finish it, but to imagine the basics, and then AI will help you, and then you can structure it as AI administrator. That's why, guys, I told you it's going to be a new field, AI administrator, and they probably will be paid like $100,000, and it's going to replace a lot of programmers, but it's going to be not that difficult. It's going to be easy to do, but as again, it requires some knowledge in that field that you're going to approach as a administrator for that particular field. This is what I assuming, and it's going to be available in the end of 2023 and heavily used in 2024, because a lot of industries will jump, well, it's going to utilize the artificial intelligence, AI. Okay, so sorry, I just woke up, guys, but I thought yesterday in the evening when I fall asleep, I better do that. Once again, please press pause. So what I'm gonna do, I'm gonna go ahead and ask it to go ahead and explain to me, signal to the threads as there no more rows to process, wait for threads. So this is multi-threading right here, and here's the trace race. This is the method that regarding the calculating and retracing calculations and algorithms. So what I'm gonna ask, this is where the basic retracing calculation would go, and I will ask, please go ahead and show me the basic retracing calculations algorithms. Okay, extend the code with basic retracing calculations and algorithms, and you can stop at this point. But what I'm gonna say like that: extend the code with the basic retracing calculations while creating an algorithms while creating scene, because it is a scene, three basic, let me put three basic primitives. Look at this. Also the primitives now. Primitives. Light. And materials. So pretty much the basic retracing scene. Okay, let's go ahead and have a look. Sure, here's an example of basic multi-threaded. It's already known it should be multi-thread retracing algorithm with the basic retracing calculation and algorithms while creating a scene. Three basic primitives: sphere, plane, and triangle. Okay, so it's gonna use sphere, plane, and triangle. Light and material implemented in C# using the system threading. Okay, oops, something is going on. Let's reload. Let's get back. It's high demand, guys. A lot of people is using, as you can see. It's always great to copy and paste your deal. Let's go ahead and just in case, especially when right now it's in the beta in January 2023, but you know, there was an error generating a response. While we are experiencing especially high demand, please hang tight as we working on scale. So they don't have enough infrastructure to support it yet. Millions of people using it. Come on. Yeah, was an error. So let me reload it. Come on. Completely, let me reload completely the whole deal. Hopefully it's going to help it. Yep, it helped. You can do it like that. This is another way to do that. And look like I gotta start a new topic. Somehow it just hang here. Yeah, I cannot. Yeah, I'm gonna start a new chat. So, let's go ahead and copy. We got already our request, so I'm not gonna continue. We got the multi-threaded, so we learned how the multi-threading is working. And let's go ahead and start with the last couple. Let's start it. What I'm gonna do, please provide, I'm gonna say it like that with the new chat, like that. Please provide C#. So we're not gonna C# as multi-thread example of basic retracing. And what I'm gonna do, I'm going to add here scene 3 primitives, light, I'm gonna close that. 3 primitives with materials, light, and let's start with that. And I'm gonna delete that one. But you can keep that one. They're not charging you guys. Safari is free. They might charge you in the future, or it might be a ChatGPT Pro version with more requests, and free version could be limited. Right now, free version is limited. They're cutting you out sometimes for 1 hour. So here's an example. So sphere, plane, and cube instead of triangle. Better use the cube. And it's creating, guys, as you can see. It's already going to put out for us the multi-thread capabilities. So, but I already have the code. I can implement that code with this code just in case. But it cannot switch between the chats right now in this public beta, one of the first public beta in January 2023. It's nice to keep everything when you're running a project under one chat. This is also a great tip. So it's creating plane, nice, cube, and sphere, pretty much 3D, and 2 materials, diffuse and glossy. Glassy could be used as metallic material with a single light source. Okay, so pretty much single as possible. Okay, here's the code. Okay, and as again, the output, how much the data it can throw out at you is limited to some characters, and you can see it if you're C# programmer or software developer. You can see that it commented but didn't close the class, didn't close this for loop, and didn't close this method trace ray, and didn't close the class, which will be the class ray tracer. Okay, so to be able, so it has some thoughts but didn't finish because it's limited in terms of the characters. So to make sure it's going to continue, you gotta type the continue. But let me go on top and see what's going on real quick. Go ahead and press the pause button. I'm just gonna go for those who's curious. Okay, as you can see, it's creating the console, but you can ask to create, I'm gonna ask it in the end to convert it probably into the application. But let's start with the console because it's going to be easy to be converted on any kind of platforms when you're using the C# programming language. So I'm gonna say continue, and it's gonna do it so nice, guys. Check it out. Continue, and let's stop at the check if the ray, and then now let's continue that comment. Intersect the triangle. Check if the ray intersect the triangle, but instead of typing in the black box, it's typing on the, it's confused now. The reason why is because a lot of people are using it and it's confused. It's completely, all the threads that they're using on their systems is capable right now, and as you can see, it's slowing down, and sometimes it doesn't have enough resources to understand that it's not typing in the black box. So a little bit of limitation, and sometimes when it's overloaded, their system are overloaded, it can do some mistakes, but then it's correcting in real time, which is great. Already in the first beta, public beta, it's correcting itself if it's going to do the mistake. But you gotta use that C# on that white that it type on the HTML instead of black box. You gotta understand it. It happens like that. Usually it's doing that when it's overloaded or when your internet connection is not fast enough. I recommend you guys to use at least 10 megabit per second internet connection, but 100 megabit per second you will be Gucci for any coding projects. Okay, so let's continue, guys. It's perfect. I also advise you to save it as PDF, the whole output, so you're gonna have the research, because in first public beta, when the server is overloaded, you cannot even connect to the point where you can read the chats. So I advise you to save it as PDF and save it offline, so you can pretty much then research it, this data, and practice it. Another tip, valuable tip for you. A lot of people was asking me how to do it, so I decided to record the multiple parts, and it's going to be multiple parts, guys. Okay, so there's going to be part 1 when we're going to see what's up, then I'm going to implement it in the C# IDE, which will be Visual Studio, try it, show it to you, and then we're going to extend the code. Let's go ahead and do the continue. As you can see, it's still doing that. It didn't finish that. We're in the middle. And this again is confused. It's not typing in black box, but it should go in black box. As you can see, it's continued that method, private void calculate lighting. So it's doing the diffuse lighting, then it's doing the specular lighting. So it can be diffuse lighting, it's pretty much like a texture, or light on the texture or light on the color. And specular lighting is when it's going to kind of create it like specular, when it's going to shine. So one light but going to generate two different resources of the output on the each 3D primitive. So calculate tara specular lighting. Okay, now instead of it should that in black box, this is a basic example and you might need to modify it. Instead of on the white, it's typing in the black, but you understand this is it's coming. It's not part of the code, and you cannot put it in a C# code because it's going to generate an error. This is just for you. It's just explaining. Okay, hopefully guys this makes sense. It's nice if you're going to duplicate this experience, if you at least know some C# syntax and develop few programs, then you're gonna be Gucci. But I'm gonna explain it to you as well. But listen to this video, rewatch this video if you're trying to duplicate this. But as again, this is going to be UHD King's ray tracing CPU benchmark, guys. Okay, and I believe that on the Windows 10 the total utilized cores can be 648 threads and 648 and 324 total cores and 648 physical threads. But we're going to ask the AI under Windows 10 operating system and professional, and under 11 it's even more, if I'm not mistaken, under the latest C#, but we're going to find out. It has the ability to utilize all the threads available on CPU, but Windows operating system has the limitation. Anyways, this is basic example, and you might need to modify it and add some classes like vector, ray, material, light, etc. Also, this could be optimized in many ways, like using memory and cache friendly data structure using VH etc. I'm not sure what it is. We're going to ask it. So the best way to do continue. If it's not going to continue, then I'm going to ask create extend with the vector 3 ray material light classes. I'm pretty much I'm going to ask it what it's telling us to do, and it's going to do it. But let's go ahead and do the continue. It's supposed to do it. Continue. As you can see on the backend server, it's creating those mistakes. So the software developer of the ChatGPT must fix that, so it's not going to write the comments in the black box and the code on the white box. It's pretty much its mistake on the back end server. I can see it as a software developer, and you can probably see it as well, and probably it's using the JavaScript while it's creating it, and they just need to correct their backend server output to the front end. Make sure it's right now it's corrected itself, but make sure it's not going to do those type of mistakes. But it could be that it's not enough resources and creating the mistakes. It could be because it's overloaded. Sometimes they're going on like that through the server, but I doubt. It's like when it's so heavily overloaded, like completely. Okay, so please note that thread pool is shared resources, so the number of threads that are available to your application can be affected by other running code. The thread pool will adjust the number of threads it's used based on current load and the number of available CPU cores, so it may not always use every thread at 100%. I ask it at 100%, so it's trying to do it 100%, but it's just explained to us because some resources will be utilized by the operating system and some other applications, but it's nice when it's explaining. This is basic example that gives you a good starting point for creating multi-threaded ray tracer. To achieve good performance, you will be likely need to optimize the code further and use more advanced techniques such as VH SIMD and memory-friendly data structure. Okay. Alright, so this is the render. So as you can see, each pixel on the image will be go through each thread on the CPU, which is great. each core can have multi-threads if hyper-threading technology used for Intel, or for AMD it's also some approaches. Wait for all threads completed, data data data. So it's completed the application and closed the the public render, but didn't close the whole. As you can see, it just created the function for us, public render. Okay, let's go ahead and continue that. And because it closed this right here, and what it is, the calculate lighting, it did the vector, so calculate the specular lighting. So we did that, we done that. We created the 3D primitives. Okay, we have the light, single light. Do we have the shadows? I don't think we have the shadows. Yeah, I don't think that we have the shadows. But as again, it's nice when you're going to implement it immediately while it's doing that. It's also a great thing. But just because it's overloaded, you probably better get the code and then play offline. As again, save it as PDF. Alright, so single light, and it's created into the render. I'm gonna ask it extend with the image saving capabilities. Pretty simple English, as you can see. You don't need to know all the terms on a C# language. Just use pretty simple English, but make sure it's making sense. It has the vector approach, that every single vertex in that vector approach, every single data point makes sense, like for the child, like 12-16 years old. Extend with image saving capabilities example in multiple formats. Let's go ahead and have a look, like JPEG, PNG, extend the code, or let's Control A, Control C to copy it just in case. Let's say continue. Let's see what's going to give us under the continuum, because it could give us some more tips. First, go with the continuum. My advice to you guys, friendly tip. And if you're gonna see it's kind of summarize it and kind of cannot approach, it tells you, okay, this is the final or summary or something like that. Then use your approaches as I already explained to you, but towards the same vector direction. And pretty much this is the way asking the question or extending the question, and it's going to extend. So as you can see, it's doing the render. Additionally, you may want to consider using parallel for each method. So it's going to give us different approaches for the multi-threading code, which is nice to know. These methods are part of the system threading task namespace, and they allow you to easily parallelize a loop. Here's an example how you can use the parallel for method to render the image. This will automatically divide the loop into smaller chunks and assign each chunk to a thread in the thread pool. Okay, to add each thread on the CPU. That's nice. So it's much more details on the multi-threaded, as you can see, even if we didn't ask it, but it's given us. So that's why, guys, it's nice to continue just to get all the tips as possible, and then to analyze the data, analyze the vector direction, and analyze where we're approaching, and then ask more advanced questions regarding that, as I already explained it to you. So the parallel for each method works in a similar way, but it is designed for use with collection of items. Another optimization techniques is to use in spatial uh, data structures such as bounding volumes, hierarchy, BVH. Nice, it's explained with BVH for the beginners to quickly find the closest intersection point. This will reduce the number of triangle ray intersection tasks that need to be performed, which can significantly speed up the rendering. So as you can see, guys, it's going to give you a lot of information like you just read 10 books. So pretty much, at least even in the beta version of the first beta version, it's replacing the scientist by 10x. And it's like a baby yet. It didn't learn a lot of things. When it's going to be the final, it's probably going to be by 100x, replacing single scientist, no matter what topic you're going to pick up. In summary, multi-threading is an important technique. Yep, that's why I asked for improving the performance of a retracer, but it's just one of the optimization techniques that can be used. Other important considerations include using the memory-friendly data structure, taking advantage of SIM D instruction, and using advanced algorithms like BVHs to speed up intersection tests. Let's ask Continuum. Let's see if it's going to explain what is the SIMD Continuum, but let's see. Hopefully the AI is not listening, guys, my mic, because if it's listening my mic, I'm not sure if I disable my mic for the Google Chrome. It could also do some additional inputs, throw at us some additional ideas and tips. Another important aspect to consider in memory management, that's great, another tip that I even didn't ask, but great to know. When performing ray tracing, memory allocation deallocation can be bottlenecked. To prevent this, it is a good practice to use object pooling, where a pool of pre-allocated object is reused instead of constantly allocating and deallocating new objects. This can be greatly reduce the overhead of the memory allocation and deallocation, kind of like a memory garbage collector idea approach. Additionally, it is also good, but manually. Okay. Additionally, it is also good practice to use a streaming architecture where each thread is responsible for a certain area of the image and the data is streaming to the main thread. This way, the main thread doesn't need to wait for all threads to finish before writing the image to the file or displaying it on the screen. You can also make use of GPU programming to speed up the rendering process, because GPU is faster than CPU, but in our case I'm going to use the CPU. This is done by using OpenCL and CUDA from the NVIDIA. If I'm going to use the GPU, I'm probably going to use the OpenCL, and it's going to be the GPU benchmark in the future as addition, because CUDA is most likely going to utilize the NVIDIA GPU as its best to offload the ray tracing computation to the GPU. This can be greatly speed up rendering process, but it requires a different programming model and specialized knowledge. Now it's switching like to a regular human being trying to act as a regular human being and explain to you like blah 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 that doesn't make no sense, senseless, like usually human beings talking to each other, but not specific. So in conclusion, now it's concluding, so now it's time to ask the questions, okay? Because if I'm going to continue, it's most likely it's going to repeat or kind of gonna give us some blah 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 that doesn't make no sense. In conclusion, multi-threading memory management, but it's generating for us some additional tips regarding multiple topics that I'm not interested but going to be useful. That's why Continuum is very crucial, guys, to use before to asking any questions. Multi-threading, memory management, and GPU programming are important techniques that can be used to optimize the performance of Retracer. It's important to keep in mind that there is no single best approach, and best solution will depend on the specific requirements of your application. It is recommended to test different approaches and techniques to see which one works the best for your use case. For my case, GPU benchmark CPU approach is the best. But if I'm going to make as fast as possible out of my PC hardware, GPU approach will be the best, because GPU at least 25 times faster than today's CPUs. Okay, and flagship GPUs will be at least 40-50 times faster than CPU, even with CPU with 128 logical threads. Keep that in mind. Anyways, let me show you Continuum. That's gonna generate some blah blah blah, and then we're gonna ask the specific questions, and you already know how to ask them. But I'm going to as well as demonstrate it for you because get better idea. Another important aspect to consider when optimizing ray tracer is to use more efficient intersect tests, such as fast ray box intersection and fast ray triangle intersection algorithms. Wow, I never saw it mentioned in the book even. Those algorithms can be significantly speed up the intersection test process, and in turn speed up the overall rendering process. Another optimization technique that can be applied is the use of adaptive sampling. This technique reduces the number of samples taken at lower complexity areas and increases the number of samples taken at higher complexity areas. This can help to reduce noise and improve the overall quality of the image. Okay, guys, this is a lot of things over here, even for the PC hardware enthusiasts and PC overclockers and graphics designer 3D artists right here, and software developers, besides the ray tracing, game developers as well. A lot of value will be provided throughout this video, so don't forget to smash that like button. A lot of time, money, energy is invested, and I promise you guys, I'm going to make multi-part of this video, so stay tuned, subscribe. There's going to be a lot of all kind of different videos available over the uhdking.com YouTube channel, and I with the one. Keep that in mind, uhdking, I with the one.com. But I'm gonna do on your favorite topics as well. So keep subscribe and keep stay tuned, and you will see. Finally, there are many other techniques that can be used to optimize a ray tracer, such as using a progressive rendering approach, using denoising algorithms. Wow, okay. This was the Jensen Huang, NVIDIA boss, was saying he's using that a lot while the GPU, and using a hybrid CPU-GPU approach, two of them. Some of those techniques are more advanced and may require specialized knowledge and experience to implement effectively. Just because my CPU benchmark will be focused on CPU, most likely I'm not going to use it, but it's good to know. So not only CPU or GPU approaches, but hybrid. In summary, there are many different techniques that can be used to optimize the performance of a ray tracer, including multi-threading, memory management, GPU programming, efficient intersection test, adaptive sampling, which is multi-sampling look like, and many more. The best approach will depend on specific requirements of your application, and it's recommended to test different approaches and techniques to see which one works the best for your case. Let's go ahead and ask Continue more and see if it's going to be over with that. Then I will start to ask detailed approaches advised by the AI, but AI is going to answer them. It asks us to read some books, but we're gonna ask the AI, which will be faster and better. And pretty much going to be as compressed knowledge at the same time. Another optimization techniques use cache-friendly data structure. Wow, never heard of that. This can help to reduce cache misses and improve the performance of the ray tracer. Wow. I read the whole ray tracing book by the Pixar that a lot of software developers recommend. Never heard about it. A common cache-friendly data structure used in ray tracing is by bounding volume hierarchy, BVH. BVH is a hierarchical data structure that is used to organize the triangles in a scene. By organizing the triangle in a way that is cache-friendly, the ray tracer can quickly find the nearest intersection point. So guys, as you can see, using the AI, you can learn a lot on a topic, even if you're not a software developer. And as again, this video will provide a lot of value. Don't forget to smash that like button. Another optimization technique is to use SIMD, single instruction, multiple data instructions. SIMD instructions allow a processor to perform the same operation on multiple data elements at the same time. This can greatly speed up the performance of the ray tracer, especially for operations that involve vectors and matrices. Another optimization technique is to use pre-calculated data, such as pre-calculating the intersection point and normals. Can also help to speed up the performance of the ray tracer. This can help to reduce the number of calculations that need to be done at runtime. Guys, you can ask the question, what is the normals? What is the intersection points? And it's going to answer. But I'm going to do it. I'm assuming that at least you have some knowledge, or I'm not looking to create this video over 5 hours. Go ahead and Google it or ask the AI yourself. In summary, there are many different techniques that can be used to optimize the performance of ray tracing, including multi-threading, memory management, GPU programming, efficient intersection test, adaptive sampling, cache-friendly data structure, SIMD instruction, pre-calculated data, and many more. The best approach will depend on specific requirements of your application, and it's recommended to test different approaches and techniques to see which one works best for your use case. So guys, as you can see, AI is trying to be focused on the techniques of the optimization, and that's what we don't want. So I'm going to switch the topic, because even if it's going to do, if this is not the summary, if he has some more idea on the topic on the retracing multi-threading, it's going to be focused on this idea, and I'm not looking to be focused on this idea. I'm looking to be focused more on retracing now algorithms. So we learn what we need to know, and then we can research using the AI those topics and find out how to do it. Okay, but let's go ahead and start to do the retracing capabilities. And so I'm going to create the shadows. I'm going to ask, please extend code with the shadows algorithms. Then I will try to add multiple lights. Extend the code with shadows capabilities and algorithms, and explain. Add shadows to the basic ray tracer. You can add a new method called trace shadow ray. Okay, didn't do that. So we didn't create any shadows. That takes a ray object, and as again, I'm not paying too much attention right now to the code, but I'm paying more attention because I'm coming in real time without any script in real time to the what AI is typing as a explanation. Object and a light object, it's a parameters. The trace shadow ray, as again, I really like the ways calling the variables and methods and classes like a human being and professional human being. The trace shadow ray method should return a value between 0 and 1 that represents the shadow factor on the intersection point. So if there is a shadow factor or not, which is nice, you can enable disable in the future then using that value. Here's an example of how you can implement the trace shadow ray method. So sometimes it's called method, sometimes it's called function, but I believe when it's called function because I know exactly what it is. I believe because under C# it should be method, but I believe when it's called function, it's just talking in general, okay? It understands the function is not under the C#, it's under different languages. Let's say like a PHP or something like that. Anyways, this is the code. Okay, as you can see, it closed the bracket, so it's done with this private float trace shadow ray method. Okay, so it's created the example of shadows that we can implement it in the, just copy and paste, and we're gonna have a shadows in the trace ray method. And now it's explained as I asked. As you can see, it's doing, try to do it in the order I'm asked in my sentence. In the trace ray method, you can then call this method and pass the intersection point, the normal, and the light sources as parameters. The result of the trace shadow ray method can then be used to calculate the final color of the pixels by multiplying the diffuse and specular lighting by the shadow factor. Here's an example of how you can modify the trace ray method to include shadows. Okay, and as you can see, it started the method, open up the bracket, created the comment, and then it's done. It's reached the limit of the characters it can throw at us. So I'm gonna say continue, and it's gonna continue the code. Guys, hopefully everything makes sense. As again, I'm explaining for a total beginner. A lot of people was asking me over my YouTube channel, uhdking.com, and this is exactly what I'm doing, exactly what I learned after a couple months using the ChatGPT, guys. It was available to us as the developers. Okay, so it's creating that. In this example, the trace shadow ray method traces a ray from the intersection point towards a light source. If the ray hits an object before reaching the light source, the intersection point is in shadow and the trace shadow ray method returns 0. Otherwise, returns 1 if it didn't hit. The final color of the pixel, so it's like true or false. The false or true. The final color of the pixel is then calculated by multiplying the diffuse and specular lighting by the shadow factor. You can also use more advanced algorithms like percentage closure soft shadows, PCSS. So now for those gamers, for those PC hardware reviewers, it's explained to you what is the PCSS, percentage closer soft shadows, and where you're gonna use it. Or variant shadow maps, VSM, to calculate. It's used to calculate the shadow factor. These algorithms give more realistic and detailed shadows, but they are computationally more expensive. So now you learn as a gamer what it's all about with explanation. And if you're a game developer, go ahead and copy this under your features of your graphic options so the user, such as gamer, will understand. Okay, look how much value I'm providing throughout this video with the help of the AI, such as OpenAI in form of ChatGPT. It's, guys, unbelievable. In summary, adding shadows to a ray tracer can be done by tracing a shadow ray from the intersection point towards the light source and using the result of this trace to calculate the final color of the pixel. That makes sense. You can use different algorithms to calculate the shadow factors, such as simple algorithm above or more advanced algorithms like, okay, it's just repeating. Okay. It says in summary, most likely we are done, but let's go ahead and continue on the shadow topic just to learn more about the shadows for the retracing. Another important aspect to consider when adding shadows to a retracer is the sampling of the shadow rays. Okay, it's explaining the shadows. In example above, only one shadow ray is traced per intersection point. This can lead to noisy shadows. Okay, explain more about shadows. So now you're gonna know when your shadows will be noisy, especially in areas where the shadow's boundary is very sharp. To reduce noise, you can use more samples per intersection point. This can be achieved by using techniques like stochastic sampling. Never heard of it before. And you can ask AI, what is this stochastic sampling? Where multiples, but it's kind of explaining to you, but you can ask details. Where multiple shadows rays are traced per intersection point, each with a small random offset. The result of these rays can then be averaged to reduce noise. Okay, it just explains some approaches to reduce the noise on the shadows. First, it tells us while the noise appears on the shadows and how to reduce it. Here's an example, very, by the way, crucial if you want to have a clean image, because retracing creates a lot of noise, guys. That's why, as it's explained, you gotta use the noiser or the noise, and it was explained also by the Jensen Huang, CEO of NVIDIA. You probably heard it as a gamer. Here's an example of how you can modify the trace shadow ray method to use stochastic sampling. Here we go. Okay, great example, but not finished. So because it's spill out of total amount of the characters, let's say Continuum get the full amount of the shadows. Guys, it's also important thing when AI gonna tell you it's very complex, you gotta read a lot of books on the topic, get some consultation. That means that your approach is complex. You gotta go step by step and use the basic approaches. If I wouldn't create a light and I would say create a global illumination, it will say it's complex topic. So that's why I created the light, because I understand. So you gotta be a little bit knowledgeable about the topic, and you gotta, as again, see where your vector is approached. Do not jump from point A to point W. Jump from point A, B, C, D of your vector direction. And okay, hopefully it makes sense. Study a little bit of topic before talking to the AI, a little bit. So in this example, the trace shadow ray method takes an additional parameter, samples, that represent the number of samples to take. For each samples, a random offset is applied to a shadow ray so that it does not always hit the same point on the object. The result of the trace shadow ray method is then the average of all samples, which will reduce the noise in the shadows. Okay, great approach. It is important to note the more samples you take, the more realistic the shadows will be, just like I explained to you guys. So to reduce that noise and make it more like beautiful without the noise and kind of softy shadows, such like that. But the more expensive the computation will be, just like in PC games, the softer shadows that reduce the noise, not harsh, it's take a lot of GPU performance, because in the PC games we're using GPU and computing the real-time retracing less than CPU, but this is the CPU approach, so that's why it's also the same kind of approach. It's recommended to find a balance between the number of samples and the performance of your application. Makes sense if you want to speed up, but in our case, I don't care about real time. performance I care about. I'm going to create a scene, and the faster it's going to complete, the faster CPU will be. The more likely, the more physical cores it's going to have, the more instruction per clock, and more threads on a CPU as well, logical threads available. In summary, to reduce noise and the shadows, you can use techniques like stochastic sampling, where multiple shadow rays are traced per intersection point and their results are averaged. This can greatly improve the realism of the shadows, but it also increases the computation cost. It is recommended to find balance between the number of sampling and the performance of your application. Pretty much it's repeating itself. When it's doing like that, most likely it's reached the conclusion and you gotta ask the question differently, or it's going to repeat itself, or it's going to say it's done, everything is done. But let's go ahead and do continue. Maybe it's gonna provide us to more tips, because as we already learned, this is something that I even didn't know. Let's see. Another optimization technique that can be used when adding shadows to ray tracing is to use shadow map. Here we go, another tip and another method, another approach. A shadow map is a 2D texture that stores the depth value of the scene from a light point of view. By comparing the depth value of intersection point with the value stored in the shadow map, it can be determined if the point is in the shadow or not. Shadow maps can be very fast and efficient, especially when used with a GPU, but they also have some limitations such as Peter panning and bias. Here's an example of how you can modify the trace shadow ray method to use the shadow map. Creating the code for us, guys. The reason why I'm commenting, just in case if you're listening it while you are exercising, let's say, and you're preparing yourself for your own complex solution to the retracing, okay, so you can listen to me and then you can copy and paste code. I will also include the code snippets in the video description or in the comments, so go ahead and check it out underneath of this video. So as you can see, throughout this video I'm going to go through the whole retracing as fast as possible without reading for you multiple books, while explaining the basics, explaining the all kind of advanced techniques as best as possible by the AI with the codes while I'm commenting, and you can listen while you're exercising or do whatever you want to do to in one value and then come back and implement. So as you can see, it didn't close the trace shadow ray method, and I'm gonna say continue. In this case, for sure, continue. So it's gonna, oh my god, it's started the code not in the black box again. That coffee with the hot chocolate is amazing, guys. I'm losing the voice because I already before that I recorded 16K UHD video for you to check out. Don't forget to check it out. It's going to be beautiful. I have already recorded 2 videos because I woke up at 4 a.m. 4:30. Okay. And of course it's coming on the black box. You cannot do that in C#. It's gonna generate an error through the debug of your debugging tool of your IDE. So it's closed right here, the method, and then this is going to be the comments that you cannot write in your code. Otherwise put the / dual bracket, otherwise it's just going to be error. In this example, the trace shadow ray method takes an additional parameter, shadow map, which is a 2D texture that stores the depth values of the scene from the light's point of view. The method first calculates the closest intersection point and then transforms the intersection point, let me go up a little bit, intersection point to the, so you're gonna see what's up, to the light space. After that, it uses the x and y coordinates of the intersection point to get the corresponding depth value from the shadow map. Finally, it compares the depth value of the intersection point with the value stored in the shadow map to determine if the point is in shadow or not. As again, it's checking probably with the boolean. Return 0 or 1, true or false, in our case false, 0 or true. It is important to note that when using shadow maps, it is essential to take care of the bias problem, which is when the shadow seems to be too close to the object. This can be solved by adding a small bias value when comparing the depth values. In summary, shadow maps are a powerful optimization technique that can be used to add shadows to a retracer. They are fast and efficient, so the fastest will be probably the shadow maps, or at least fast, comparing to the previous methods, especially when used with the GPU, but in our case CPU. But they also have some limitations such as Peter panning and bias. To use shadow maps in a ray tracer, you need to calculate the closest intersection point, transform the intersection point to light, and it didn't finish because there is no dot, so I'm gonna say continue. To light space, and let's continue. Use the x and y coordinates of the intersection point to get the corresponding depth value from the shadow map, and then compare the depth value of the intersection with the value stored in the shadow map to determine if the point in the shadow or not. One important thing to keep in mind when using shadows maps is to take care of the bias problem by adding a small bias value when comparing the depth values. Another thing to consider is the resolution of the shadow map. Okay, so now we understand why shadow map using the resolution as well. You can see it in a lot of PC games or any games that using the 3D rendering in real time on GPU. But as you can see, this technique can be used for the CPU, but the best applied for the GPU. But as again, I'm gonna use it as the CPU first. The higher the resolution of the shadow map, the more accurate the shadows will be, but the higher the computational cost will be. Makes sense. Finding the right balance between the resolution and performance is important. As again, based on your PC hardware specification. Completely makes sense, right? As a PC hardware enthusiast or a gamer. Additionally, you can use more advanced techniques like cascade shadow maps, which divide the view frustum into multiple levels and use different shadow maps for each levels, or shadow maps filtering methods like PCF, percentage closure filtering, or VSM, variance shadow maps, to improve the quality of the shadows. In conclusion, adding shadows to a retracer can be done by using shadow map, which is a 2D texture that stores the depth values of the scenes from the light's point of view. Shadow maps can be very fast and efficient, especially when used with the GPU. But it is important to consider the resolution bias and other techniques like cascaded shadow maps and shadow map filtering methods to optimize the performance and the quality of the shadows. So in our case, I don't care about the speed. I care about to make it as heavy as possible because I'm thinking in the future. So we're going to utilize even the CPUs when they're going to come out with the 1024 physical cores or 2048 logical threads. But as again, I do not believe that Windows 10 or even Windows 11 operating system is capable to support 12,048 logical processors or logical threads. We're going to ask the AI, okay, in the future, based on operating system. It's going to be limited by the operating system because Microsoft is artificially limiting the capabilities of the threads throughout their professional edition of the operating system. This is what I learned since the Windows XP, home versus professional. Okay, let's click continue if in case it's going to have any other tips in terms of the shadows. If not, I'm going to switch the topic. Yes, it does. Another thing to consider when adding shadows to a retracer is shadow resolution. We heard this already. The higher the resolution of the shadow maps, the more accurate the shadow will be, but the higher computation cost will be. I don't care about the computation cost. The heaviest as possible is better for us because this is going to be a benchmark. As I already explained to you, I'm going to utilize all the cores and all the threads and to stress it probably for the longer time as possible, so I can utilize all the available cores and threads in the future. Finding the right balance between the resolution and performance is important. Additionally, you can use more advanced techniques like cascade shadow maps, which will divide the view frustum into multiple levels and use different shadow maps for each level, or shadow map filtering methods like PCF, percentage close-up filtering, or VSM, variant shadow maps, to improve the quality of the shadows. So it's repeating itself, guys. We already heard this, exactly the sentences. Maybe it's rephrased just a little bit, but I already heard that. That this is new things for me. I never heard this before this AI, but we already heard this AI was stating to us. Another optimization technique that can be used while adding shadows to retracer is to use the shadow cache. Shadow cache stores the results of the shadow calculations, so they don't need to be recalculated each time the same intersection point is reached. This can improve the performance of the retracer, especially when the scene is complex and has a lot of triangles and lights. It is important to note that the performance of the shadow cache will depend on the specific requirements of your application, and it's recommended to test different approaches and techniques to see one works best for your use case. Makes sense. So it tells us how to do the optimization, especially on the heavy scenes, to render as fast as possible with better results and better techniques and all kind of approaches. So it's kind of not some repeating, but a lot of repeating, but as again, continue was valuable in our case. In summary, adding shadows to a retracer can be done by using a shadow map, stochastic sampling, or other advanced algorithms like PCSS or VSM. It is important to consider the resolution bias, shadow cache, and other techniques like cascade shadow maps and shadow maps filtering methods to optimize the performance and the quality of the shadows. Okay, I think it's done, but let's go ahead and continue. If it's going to repeat it, we're going to switch. I'm going to add the multiple lights to our scene. And after that, I'm going to add multiple materials. Then I will add the caustics. It's thinking. Hopefully it's not. Come on. Come on. I think it's searching, but could be overloaded by the usage of the millions of users' requests. Come on. Guys, if it's going to tell us we gotta come back, sometimes it does it. As I showed you how to try to get rid of that message at the beginning of this video, but if it's not going to be fixed, then it's going to be, I'm going to add this part 1, then part 2, I'm going to implement this in Visual Studio. Then I'm going to record part 2 for you, and then we're gonna advance the code with part 3. Hopefully it's going to be at least 3 parts, and it will be available over the hdking.com. But as you saw, you learned so much information, it's unbelievable. In the software development, in retracing, and rendering in real-time graphics, rendering 3D in real time. Oops, that's it. Okay. And this is a bad news for us, guys. Let me go ahead and do the refresh. If it's not going to be fixed, we're in deep trouble. The box is here, so I'm going to ask some more. We're not in trouble, it just was some error, it just couldn't proceed. Let's go ahead and repeat it. And as again, it's also a great idea to copy your request. Control C, Control A to select it all, whatever you're typing, and Control C to copy, and then Control V to paste it. But as again, I didn't type the whole sentence, I just did the continue. So I'm gonna ask continue. It's probably cannot allocate some stuff. Another optimization, now it's allocated. It probably was doing some research. There's a possibility. Or it was overloaded by the, as again, million of user requests. Another, yes, it's great to continue. Another optimization technique that can be used when adding shadows to a retracer is to use spatial data structure like bounding volume hierarchy or octree. This is something new. This data structure can be used to partition the scene into smaller and more manageable parts, making it faster to trace shadow, erase, and find intersections. This is something new, guys. Here's an example of how you can use BVH to optimize the trace shadow ray method. Okay, I think we heard this already, and this is not new, but it's explained to us some new method, which is the octree. In this example, the trace shadow ray method takes an additional parameter, BVH, which is an instance of BVH class that has been built with the scene geometry. This method uses the BVH to find the closest intersection point, which can be faster than checking every triangle in a scene. It is important to note that building the BVH can be a time-consuming process, but once it's built, it can greatly improve the performance of the retracer. So as you can see more about optimization. So look like AI is focused on the optimization, and you can see which topics it focuses on. So you can see the vector data point of the vector direction. The performance of the BVH will depend on the specific requirements of your application, and it's recommended to test different approaches and techniques to see which one works best for your use case, or to implement in your application so user can test it. It depends, what kind of application you're developing, what kind of needs. Most likely I'm going to implement all kind of different features for the user to use and to manipulate. Instead of just static code, I'm going to make it dynamic, and user will check mark, enable this, enable that, or automatic or static. It depends to my benchmark, but it's going to give an additional feature of the benchmark. In summary, using spatial data structures like a BVH or an octree can be useful optimization technique when adding shadows to a retracer. This data structure can be used to partition the scene into smaller and more manageable parts, making it faster to trace shadow rays and find intersections. The performance of the BVH will depend on the specific requirements of your application, and it's recommended to test different approaches and techniques to see which, and as again I didn't finish the thought, so continue of course, which one works best for your case. Another thing to keep in mind when adding shadows to a retracer in the memory usage, the shadow map at the BVH can take up to a significant amount of memory, especially when the scene is complex and has a lot of triangles and lights. To reduce the memory usage, you can use techniques like tiled shadow maps and other techniques, where the shadow maps is divided into smaller tiles and only visible tiles are rendered and stored in memory. So we just learned a lot of techniques, guys, to reduce the memory usage. Tiled shadow mapping, tiled shadow maps. So most likely you're gonna see it in the future, guys, in the PC games as well. It's also important to note that the code I provided is a basic implementation and it's not optimized for performance. But AI provided a lot of tips, guys, and now you can play it, manipulate it, and see which one is best works for your needs. There are many other techniques and methods that can be used to improve the performance of Retracer, such as using SIMD instructions, multi-level BVHs, and adaptive sampling. Okay, now we learned about shadow adaptive sampling, another technique, and you can ask the AI. In conclusion, adding shadows to a ray tracer can be done by using shadow map, stochastic sampling, or other advanced algorithms like PCSS or VSM. It's important to consider the resolution bias, shadow cast, spatial data structure like BVH or octree, tile shadow maps, memory usage, and other techniques like cascade shadow maps and shadow maps filtering methods to optimize the performance and quality of the shadows. Guys, I just learned so much information about the shadows in 3D, in retracing 3D, in rendering as retracing approach. I just got too much water. Apologizing about this. This is not the COVID. Thanks God I wasn't sick in COVID. Let's see, continue. Let's see if maybe some other. We just learned a lot of. So continue is very useful function, guys. Do not speed up. Do not ask the direct questions. Try to see what AI can offer. So this continue option under the ChatGPT is very useful, guys. And when the AI will be like, there is nothing else I can provide, it's gonna tell you, and try to tweak it, continue a little bit more. If it's gonna say there is nothing else I can provide, try to come back, because the AI is using the machine learning. It's learning, a lot of learnings going on through all kind of different approaches. So maybe in 1 week, 2 weeks, it's gonna generate different or additional tips and the techniques that can be used. Keep that in mind. This is another tip for you. Additionally, it's also worth mentioning that are other types of shadows that can be implemented in a ray tracer, such as the soft shadows and area lights. Soft shadows are shadows that are not completely sharp, but have a certain degree of blurriness, which can make a shadows look more realistic. Okay, we just learned how to make shadows more realistic. Area lights are lights that have a defined areas rather than a point light source, which can be used to create more realistic and soft shadows. Implementing soft shadows and area lights can be more complex and computationally expensive than the basic techniques I have discussed so far. These types of shadows can be implemented using techniques like adaptive sampling, path tracing, and photon mapping. We just learned some new terms, guys, and as again, you can put it down and ask the AI later on details regarding those terms. It's also important to keep in mind that adding shadows to ray tracer can be a complex task, and it is recommended to start with a simple implementation and gradually add more features and optimization as needed. It's important to test the performance and quality of the shadows in the different scenarios and find the right balance between performance and quality. In summary, adding shadows to a ray tracer can be done by using different techniques and methods like shadow maps, stochastic sampling, BVH. I never heard the BVH before. Now we're gonna know what is the BVH. Now I know exactly what is the tile shadow maps, soft shadows, and area lights. However, now soft shadows as well, guys. And it was explained how to make those soft shadows more like realistic. However, implementing soft shadows and area lights can be more complex and computationally expensive than the basic techniques. It is recommended, but soft shadows look like going to be more photorealistic. So if you're gonna create your photorealistic scene, you know exactly where you're going to take your vector approach. It is recommended to start with a simple implementation and gradually add more features and optimization as needed. Finding the right balance between performance and quality is important. It is recommended to test the performance and quality of the shadows in the different scenarios. Let's go on to continue. I really like that. It's worth noting that the code example I provided is the basic implementation of Retracer with shadows and may not be suitable for production use. Maybe talking about real time, but I don't care about real time 3D rendering. It could be not real time. I'm gonna make a scene as complex as possible to utilize all the CPU threads that is available and to make it like probably for minute or 10 minutes rendering. So the task can be used 10 years from the time when I'm going to develop the benchmark. So I'm thinking towards the future. When you are developing the application, you want to always think towards the future, guys. Alright, let's get back to the AI. It's also worth noting that there are many libraries and frameworks available that can be used to create a retracer, such as Unity or Unreal Engine. Okay, I know exactly about those, which the two of those are the best, by the way, in 2023, which have built-in support for real-time rendering and lighting. Additionally, it's also important to keep in mind that there are other factors to consider when creating a retracer, such as anti-aliasing, reflection, and refraction. Those features can be added to the retracer to create a more realistic and visually pleasing image. So guys, as you can see, when you're developing games using Unity and Unreal Engine, you can use the ChatGPT or OpenAI to release like unbelievable amount of help that you're not gonna learn in any schools. So the university schools are done, guys. You're gonna see a lot of discounts and such, especially by the end of 2023. But you don't need to go there. All what you gotta have the assistant AI as assistant, and you Gucci, and you can pretty much, guys, be a god now. Okay, with the AI, this is unbelievable. Those type of technology, guys, Yahoo has evaluated this type of technology as 600 billion in beginning of 2023. Microsoft invested 10 billions, and another companies invested 30 billion. So the company is worth 40 billions in about 1 month and a half after it launched free public version, first public version in beta of the ChatGPT under OpenAI. Guys, I think it was trillions of dollars, okay? Trillions of dollars in 2023. All right, let's get back to the AI. The code example I provided is a basic implementation and may not be suitable for production use. There are many libraries and frameworks available that can be used to create retracers such as Unity and Unreal, which have built-in support for real-time rendering. I don't care about real-time rendering, but this is the fastest rendering, keep that in mind, and lighting. It is important to keep in mind that there are other factors to consider when creating a retracer, such as anti-aliasing, reflection, refraction, in order to create more realistic and visually pleasing image. Okay, so this is what we're gonna ask now for the retracing capabilities. Anti-aliasing, I'm going to ask the reflection and refraction. But before, let me continue. Let's see if it's all. Too many requests in 1 hour. Oops, that's it. Very limited, guys. So as you can see, ChatGPT free version has a limited amount of the requests per hour, and then it's gonna ask you to come back in 1 hour. Okay, and I believe that's why they will release the ChatGPT Pro, and they're going to charge for a monthly fee, and it's not going to be limited. But this is just unbelievable. Let's go ahead and refresh, and let's go ahead and try to use the box is still here. So refresh, as you can see, can do the trick right now, but could be fixed in the future. But this is another tip for you, how to do it now without waiting 1 hour. So I'm gonna go ahead and do the continue. Let me see. Let's go ahead and start continue. Let me get all the way down. Wow, we got so much, guys, research done. And as you can see, guys, this is how I'm doing research, and I'm explaining to you as best possible ways, and everything makes sense. I know if you're not a beginner, probably too much for you, but as again, a lot of people are beginners and a lot of tips are provided, so don't forget to smash that like button. Okay, the box is not here, so what we I mean, it's here but it's not usable. So what we can do, we can jump to quantum physics, get back. Maybe it's limited to the chat, to single chat. Let's try it again. I'm gonna say continue. Trying to tweak it. Nope. Let me see, continue over here. This one is locked. Something, AI didn't like something here. Under the So if it's going to be locked, guys, we're going to be done. So we're done with the shadows and such. Then I'm going to come back to reflection, refraction, and anti-aliasing. But before we're going to do that, I would like to add the texture to the primitives. We just did the colors, which is the materials, and under the materials I would like to add the textures, and then we're going to jump into reflection, refraction, and then I'm gonna do the caustics. Yeah, after ask something crazy, and yeah, I didn't like that. Please, come on. Maybe I'm gonna start a new chat if it's not going to work. Let's see if it's going to work. It's locked. Too many requests in 1 hour. Maybe it's locked under Continuum. Maybe or just per user. Let's see. Let's go ahead and extend the code with textures. Capabilities for primitives. No, it's locked. That lock. Let me start new chat. Let's see if new chat. Let me say hi. Nope, it's locked. So we're locked. We gotta wait 1 hour, guys. So look like that's it. So this is going to be the part 1. I will try to go ahead and implement this in Visual Studio. I'm going to use the Microsoft Visual Studio, one of the C# IDE. And I will go ahead and implement this, but pretty much let me go slow. Go ahead and press pause for those who's curious. And you can do it probably too and see how it's going to work out. Usually the AI produces no mistakes. Sometimes when it's overloaded or when it's not overloaded, sometimes it could do mistakes, but it's correct. It's on the fly and it's gonna let you know, look, there is a mistake. Here's the corrected version, and it does it automatically, which is unbelievable. Let me go through it. Go ahead and smash that pause button. As you can see, sometimes it was writing the code not in the black box, so please keep that in mind. We're almost done over here. I'm just trying to underline it for you. As again, guys, don't forget to smash that like button. Throughout this video, you just learned gazillion of the information, and a lot of time, money, energy is invested. I could do it by myself, but I decided to go ahead and share it with you. I decided not to be as selfie. I decided to go ahead and share it with you guys, so you can benefit through the information. You can learn what is the AI, how to use the AI. This was the example how to develop the softwares while using the AI, but I'm also using the AI while creating the graphics, as I already explained to you, through my cinematic modes for the games such as that will improve the visual capabilities of the old school games to bring the visual image, final visual image rendered in real time to another level, such as graphics will be from like 2018, 2040, from the games like in 1997, 2001, 2005, and I'm using the AI as well. But now you can use, guys, the AI also to improve the code. Unbelievable. You can pretty much compile the code of the game, load it into the AI, and ask how I can improve the code. If the game, I will try to do it, guys, actually, in my modes, cinematic mode. So stay tuned, guys. Stay tuned. We're going to have a lot of goodies, a lot of unique content available over the uhdking.com. Don't forget to smash that like button, guys, as again, and share it with your friends. A lot of information you learn. Trust me, friends will thank you, and I am thanking you in advance to share it, to smash that like button, to subscribe for more great videos. Please, positive comments, guys. Do not write any stupid comments. Positive comments relating to the topic, and visit my sponsors. I'm going to collect those paintings, so we're gonna do more computer science. I'm going to invest that back into you. I'm going to buy more PC hardware. I'm going to develop my own AI. I'm going to create the tutorials how to develop your own AI at home while utilizing your Tensor cores on your NVIDIA video cards on your NVIDIA GPUs. or how while to utilize the narrow colors on your AMD Radeon video cards. You don't want to miss it, guys, and all what I'm asking you just to smash that like button, share it with your friends. And as you can see, Google is suppressing me because they don't like the true stellars. They like the people that doing the idiotic things and promote the stupidity. But as you can see, I'm not about trending, I'm about what makes sense. Okay, so you saw what it is. I'm going to ask for more, last time for the AI to create extend the code with textures with applying ability of applying textures to the primitives with an examples with an example of ability of applying textures to the primitives to the primitive. Some could be color, some can be texture. Nope, an error appear, but at least it doesn't tell us that. Let me see, it doesn't tell us that. Let me ask over here. Yeah, there is a help error occur. So I gotta come back in 1 hour, guys. Yep, I refresh it and this is what it tells us. High demand, data. But wait a second, maybe it's gonna take it. Let's go ahead and have a look. Nope, 1 hour. Alright, guys, so I will see you. So part 1 is over. Stay tuned for part 2. And as again, this was the huge decaying retracing CPU benchmark that I'm trying to develop as transparent as possible. This is going to be my new approach. I'm going to drop that project in Java and I'm going to move into C#. I'm going to use the AI. So it's going to be, guys, beautiful. It's going to be amazing. It's going to be on another level and it's going to be so futuristic. So you don't want to miss it. Have a good morning, good day, good evening. Thank you so much for watching and I will see you till the next time. Check out the video description and video comments for more great information related to the topic.